Welcome to the Explainer. Today, we're taking on a genuinely fascinating and, frankly, pretty complex challenge: migrating small business administration, or SBA, data using knowledge management in data science, what we usually just call KMDS. Now, if you've ever found yourself just staring at a completely empty Git repository, kind of scratching your head and wondering, how on earth am I going to turn this blank slate into a fully functioning, production-ready machine learning model? Well, you are definitely in the right place. We're going to walk through a highly structured workflow that takes us all the way from literally the first lines of configuration straight through to making those absolutely crucial featurization and modeling decisions. So let's map out exactly how this journey from zero to production actually plays out in the real world. Okay, let's dive right into this. We've got a fairly dense 11-step process ahead of us, but we're treating it like an assembly line blueprint to keep it super manageable. It's broken down into 4 main phases. First, laying the project foundation. Then, bootstrapping and configuration. After that, scrubbing and parsing data. And finally, featurization and modeling guidance. So, starting right off with phase 1, laying the project foundation, building the scaffolding. Here are the first 4 steps of our assembly line, and honestly, watch how fast this scaffolding goes up. Step 1 is simply setting up a new Git repository. That's the bedrock of our whole project. Step 2, we initialize a UV project. And if you're using UV, you know it's an incredibly fast Python package manager, so our environment gets tuned up right away. Now, step 3 is crucial, installing KMDS and its dependencies, but pay special attention to the installation of the KMDS UI package here. We absolutely need this because it's what allows us to visually map out and explore our resulting knowledge graph later on. Finally, step 4 is just running the init workspace utility to generate an alias to our workspace image file. And boom, just like that, in 4 quick steps, the foundation is completely poured. Let's transition right into phase 2, bootstrapping and configuration, organizing the assets. For steps 5 and 6, we get to rely on some pretty brilliant smart tools that essentially do all the heavy lifting of project organization. It really takes a massive burden off your shoulders as a data scientist. First up, you run the location helper utility. This little tool analyzes your workspace and basically tells you exactly where to place your project artifacts. Then you run the bootstrap config utility, which generates a provisional configuration file for your data cleaning. From there, you just double-check your working directory, rename that file from provisional_config.yaml to just plain old config.yaml, and you're set. Inside that config file, you'll specify exactly which entities need to be tagged for feature engineering. So for this specific SBA example we're targeting geographical addresses, meaning we're specifically hunting for latitude and longitude. Now, what's really interesting about this slide is how we bridge that configuration over to actual data parsing in step 7. By running the Classify Entities utility, the system automatically generates these parser handshake filters. It's a pretty clear relationship. We feed in the raw geographical addresses as input, and the output gives us those precisely extracted latitude and longitude tags. Basically, these handshake filters perfectly format our tags so they're totally ready to go for the next stage of the pipeline. Moving right along to phase 3, scrubbing and parsing data, where we really start refining our raw materials. All right, in steps 8 and 9, we get to unleash the AI-assisted cleaner. When you run the Clean Dataset utility, the system immediately spits out a really comprehensive data profile. I'm talking a highly detailed clean or null report right alongside specific recommended cleaning actions. But, and this is absolutely key, we don't just blindly accept whatever the AI tells us. We make a crucial pivot into our Jupyter notebooks. Specifically, you're going to open up clean_SBA dataset.ipymb. This is where you roll up your sleeves and meticulously examine those tagged entities, the proposed dataset types, and all those cleaning recommendations. Actually, I want to pause for a second and really emphasize this point. AI cleaning recommendations are provisional. They absolutely require human validation. This whole human-in-the-loop motif, it's woven throughout this entire architecture. You are the hero of this story. The AI is just a really powerful assistant that speeds up the pipeline, sure. But you have to manually validate these provisional type assignments to guarantee the actual integrity of the data. So that leads us to the big million-dollar question. We've got our Get repo, our config files are perfectly tuned, the parser handshake filters are active, and our data is scrubbed incredibly clean. How do we actually take this pristine data and build a real production-ready model out of it? Which brings us to our final phase, section 4, featurization and modeling guidance, the human touch. Let's move to end and see how this builds out the climax of our workflow. First, we inspect the metadata that was generated by the parser. Next, we run a brand new notebook. feature underscore advisor underscore SBA underscore example.ipynb. This component is incredible. It acts as a featurization advisor, serving up tailored recommendations on what actually makes sense for this specific, unique dataset. Following those recommendations, we then explicitly encode our geographic attributes into those latitude and longitude variables we found earlier. And once those spatial features are totally locked in, we can finally start developing our clustering model. And this brilliantly illustrates exactly what our clustering model is trying to achieve. Basically, we are fundamentally trying to differentiate between two main clusters here. Good loans, the ones that are paid in full, versus distressed loans. By mapping out our data points using those geographic attributes alongside some other features, our ultimate goal is to derive a very specific mathematical metric. For every single loan in the entire dataset, we want to calculate a distance feature. We literally want to measure exactly how close it is to the nearest good cluster and exactly how close it is to the nearest distressed cluster. To put that final professional polish on our finished product, we really need a measured analytical approach here. As we derive those distances to the good and distressed clusters, we also have to create accounts for any category levels that, just don't have enough data support. We have to meticulously account for any lingering missing values in the dataset. And above all else, every single one of these featurization decisions has to align perfectly with the design decisions found in the agent_documents directory. That is absolutely crucial, because that directory is what outlines our core problem framing and our ultimate criteria for success. We've honestly covered a massive amount of ground today, from initializing a blank workspace all the way to calculating complex distance features in a clustering model. But I want to leave you with this really vital thought taken straight from the source material. Data science experience, expertise, and judgment are critical skills in developing the model, even though the solution is AI-assisted. The tools we walk through today, the config bootstrappers, the AI cleaners, the featurization advisors, they are insanely powerful. But your domain judgment is what actually makes the whole solution work. Which leaves us with a pretty fascinating question to ponder. As AI tools continue to get sharper and sharper, will they ever fully automate this kind of pipeline, or will human judgment remain the ultimate irreplaceable feature? Dive into the repository and find out for yourself.